Suppose there is a person who travels 4 kilometers in east and then turns left and takes 4 more kilometers in north and reaches this point. Now the path that he has actually traversed is 8 kilometers, and it is the definition of distance. That is, the distance covered by an object is defined as the path that the object has actually traversed. Now he is not 8 kilometers away from the initial position. He is indeed 4 root 2 kilometers away from the initial position and in northeast direction. So his final position with respect to initial position has not only a magnitude but also a direction, and hence it is a vector quantity, and this quantity is known as displacement. So displacement between the 2 points is usually this straight line. Now what if the person has taken this path like this? Even then his displacement would have been the same, that is 4 root 2 kilometers. Even if he takes the path like this, suppose, even then it will be the straight line between these 2 points. So displacement will be the same regardless of whatever path he has taken. Now from here we can infer one thing: distance can be greater than displacement. And what if the person travels like this in the straight line following this path? Then in this case distance will be equal to displacement. So distance is greater than or equal to displacement. Now we have understood what is distance and displacement. Let's do some problems based on distance and displacement. So let's do first problem. Let me draw a circle over here like this. Let me use a red color. Yeah. Suppose this is a circular road, and on this road a cyclist here at this red point is cycling along the circumference of this road. Now let's say he starts here at this position A and ends here at B. Now the question is, let's say the radius is A. Now the question is, what is the distance traveled by the cyclist? The distance traveled will be 1/4 of a circumference. So 1/4 of a 2 pi r, not r, it is A. So 1/4 of 2 pi A will be pi A by 2. So pi A by 2 units is the distance covered by the cyclist. Now what is the displacement? Displacement, as I have earlier told, will be the straight line between these 2 points, final and initial points. So we know this is also radius A, so this will be root 2a. So the displacement will be root 2a. The magnitude of the displacement will be root 2a. And what is the direction? Suppose again I extend it over here. So this is A and this is A again, and let's say this is alpha. So tan alpha will be opposite side upon adjacent side, that is 1. So alpha is equal to 45 degree because tan of 45 is 1. Now let's do another scenario. Suppose here I'm again drawing a circle like this. It has become red. It's okay. Let's use another pen now. Green color. Okay. Suppose the cyclist is again at this position A, and now he reaches this position B like this. So he has taken the path like this. Yeah. And this is the diameter. Again, let's say the radius is A. Now what is the distance traveled by the cyclist? Distance will be 2 pi A divided by 2. That will be pi A. And what is the displacement? Displacement will be 2a, because the change in the final position and the initial position is 2a. So this is 2a in this direction, that is alpha is equal to 90 degree now. A vector of length a is turned through an angle alpha about its tail. What is the magnitude of the displacement of its tail? So there is this vector whose length is a, that is the magnitude is a, and it is turned through an angle alpha about its tail. So this is the tail, and I will turn this vector like this about its tail. And what is the magnitude of the displacement of its tail? So this is vector a bar, suppose, and this is vector b bar. This is actually the vector with the magnitude same as the initial vector, that is this one vector. So this vector's magnitude is a, and the angle between them is alpha. Now the displacement vector will be like this, as I have earlier said, that initial position, final position minus initial position will give you the displacement. Now let's say this vector is c bar, the displacement vector. Now we know from the vector addition, a bar plus c bar is equal to b bar, from the triangle law of vector addition. So that this becomes a bar minus b bar is equal to minus c bar, or I can write c bar is equal to b bar minus a bar. Now let's dot these two with themselves. So this becomes b bar minus a bar dot b bar minus a bar. So this becomes c square is equal to b bar modulus square minus 2a bar dot b bar plus a bar modulus whole square. Now b bar modulus is a, so a square minus 2a square cos alpha plus a square. So this becomes 2a square minus 2a square cos alpha, and 2a square let me take common, into 1 minus cos alpha. So 2a square into sine square alpha by 2 will be c square. So c will be square root of 2a sine alpha by 2. So this is the magnitude of the displacement of the tip. What is the displacement of the point of a wheel of a radius r initially in contact with the ground? So let me draw a diagram over here first. So this is my wheel and it has point over here. Let me draw a little straight line. Yeah. So this is the point which touches the ground, and the radius is r. So what is the displacement of the point of a wheel of radius r initially in contact with the ground when the wheel rolls forward a half revolution? So now the wheel will roll and reach some configuration like this. Because it has rolled forward. Now this point will come here at this position. Why? Because it has done a half a revolution. So in a half a revolution, this point will go to this, and by simultaneously it will move forward, the wheel will move forward, so it will be somewhere here. So this is my diagram, and now I am done with the problem actually, because now there is nothing more left to do, like nothing more difficult left to do. So this is the length, this is 90 degree. So what will be this? It covers half a revolution. So 2 pi r divided by 2 will be pi r. So this is pi r. And what will be this? This will be 2r. Now the distance between these 2 points, that is the straight line between these 2 points, is my displacement. not distance but displacement. So this will be pi r whole square plus 2r whole square is equal to x square. So what is x square then? Pi square r square plus 4r square so this becomes, let me take r square common, so this becomes r square plus r square into pi square plus 4 and this is x square. Now let's take square root on both sides, so x is equal to pi square plus 4 into r. So this is the displacement's magnitude. Now what is the direction? Let's say the angle is alpha, so tan alpha is equal to opposite side 2r divided by adjacent side pi r, that is 2 pi pi. So alpha is equal to tan inverse of 2 by pi. So this is the direction of the displacement. Now suppose there is an ant. So let's say this axis is x-axis, this axis is y-axis, and this axis is z. This is a room, the cubicle room, and there is the ant situated over here, and let's say the side of the cube is A again. Now this ant travels from this point O, suppose, to this point P like this. It takes first this distance, it covers this distance first, then it covers this distance, and then it covers this distance. So what is the distance traveled and what is the displacement? Now what will be the distance? Distance will be this A plus this A plus this A, that is 3A. So the distance traveled by the ant is 3A. Now what is the displacement? Displacement will be this. So the relative position of the final position with respect to initial position. So this will be my displacement, that is the body diagonal of the cube. Now how to know the magnitude of this? So let me draw the straight line here like this. So let's say this point is Q, so and let's say this point is R. So this triangle ORQ is a 90-degree triangle, that is angle ORQ is 90 degree. So what is this? This will be root 2A by using Pythagoras theorem, and this is A again. So the distance OP is distance between OP, that is the magnitude of my displacement, is equal to root 2A whole square plus A square and square root of that. That will be 2A square plus A square and square root of that, and that then becomes square root of 3A square, that is square root of 3A units. So this is the displacement, the magnitude of the displacement. And what is the direction? Let's say the angle is alpha over here, so tan alpha becomes opposite side A upon adjacent side root 2A. So this becomes, this gets cancelled, so tan alpha becomes 1 by root 2. So alpha then becomes tan inverse of 1 by root 2.